Hi guys, welcome to pencilcollege.com. Okay, so in this video we'll be moving on to more examples in chapter 12.1. Okay, without further ado, let's go straight to example number 3. Okay, given that x equals to 2 sine theta and that y is equals to cosine theta plus 1, show that the following equation is equals to 4. Okay, so what will we do? Let us just substitute the given functions for x and y into the equation. So let's call this equation number 1. Okay, so if I were to sub x equals to 2 sine theta and y equals to cosine theta plus 1, okay, into equation number 1, okay, what will I get? So 2 sine theta square, okay, this is my x square, plus 4 times y, which is cosine theta plus 1, minus 1 whole thing square. Okay, let me just simplify this. So 2 sine theta square, okay, is similar to 2 sine theta times 2 sine theta, which is just 4 sine square theta, okay, plus 4 times cosine theta plus 1 minus 1 is just cosine theta square. Okay, so at this point, let me just remind everyone that cosine theta square is equals to cosine square theta. Okay, these are the same. Okay, so this will just give me sine square theta plus 4 sine square theta plus 4 cosine square theta. Okay, factorizing out the 4, I will just get 4 sine square theta plus cosine square theta. Okay, and then using the first identity on the top left hand corner of your screen, this is just 4 times 1. Okay, and finally this is just 4. And I've shown what the question wants me to show. Okay, so I think this example is relatively easy. Okay, let's move on to the next one. Okay, in example 4a, we're asked to prove the following identities. Okay, so on the left hand side of the equation, I have secant x minus cosine x. Okay, and on the right hand side, I have sine x multiplied by tangent x. So for those of you who have forgotten what is secant x, okay, it is just the function that you see on the top left hand corner of your screen. Okay, so to prove some identities, okay, I will either move from the left hand side or the right hand side. So perhaps in this case, I will try to go from the left hand side. So LHS stands for left hand side. Okay, so the left hand side is secant x. Okay, so secant x is just 1 over cosine x, okay, minus cosine of x. Okay, and in order to subtract these two fractions, I will need a common denominator. Okay, so this is just this. Okay, and then cosine x can be written as cosine square x over cosine x. Okay, so the common denominator will just be cosine x. Okay, so combining the numerators, I'll get this. Okay, and the denominator will stay as this. Okay, so take note that, okay, recall this identity that we learned previously. So sine square x plus cosine square x is equals to 1. Okay, and if I were to shift the cosine square x to the right hand side of this equation, then sine square x is just 1 minus cosine square x. Okay, so I can replace 1 minus cosine square x with sine square x. Okay, so since I'm sort of out of space, let me just continue over here. So sine square x divided by cosine x can be written as sine x times, okay, this dot over here means multiply, sine x over cosine x. Okay, and then finally, we all know that sine x over cosine x is just tangent x. Okay, and then we have shown that this is equivalent to the right hand side of the equation or the identity. Okay, and I'll just end by saying shown, or okay, or you can write proved. Okay, both are the same. Okay, so let's move on to the next example. Okay, in example 4b, this is something slightly tougher. I'm asked to prove the following identities. Okay, so what I will do, I will be making use of the second identity you see on the top left hand corner of your screen. Okay, so let me start from the left hand side of the equation. Okay, note that it's not a must to start on the left hand side. Sometimes you might want to start on the right hand side. Okay, it might be easier sometimes to start on the right hand side. Okay, so for the left hand side of the equation, okay, what I'm going to do, okay, I will replace 1, okay, I will expand it out. Okay, so 1 plus tangent theta square is just 1 square plus 2 times 1 times tangent theta, okay, plus tangent theta square. Okay, so recall that a plus b square is just a square plus 2ab plus b square. Okay, so this is what I'm using, okay, over here. Okay, so how about this? 1 minus tangent theta square. Okay, this is just 1 minus 2 times 1 times tangent theta, okay, plus tangent theta square. Okay, so simplifying this whole row of expression over here, 1 plus 1 will just give me a 2. Okay, 2 tangent theta minus 2 tangent theta will be gone. Okay, and finally tangent square theta plus tangent square theta will just give me 2 tangent square theta. Okay, and then I can factorize out my 2, so this leaves me with 1 plus tangent square theta. Okay, and finally, okay, using the second identity you see here on the top left hand corner of the screen, okay, this is just secant square, okay, secant square theta. Okay, so I'll write proved. Okay, so I hope you have understood this example. Okay, so just to summarize this chapter, okay, we have learned some trigo functions and we have learned some trigo identities. Okay, so the trigo functions that we have learned in this chapter are summarized on the left hand side of the screen, and the identities are summarized on the right hand side of the screen. Okay, so you might want to pause the video here and take this down. Okay, it's very important. Okay, and before I end off, I'll just leave you with some practice questions. Okay, thank you for watching this video. For more videos, please log on to pencilcollege.com. See ya!